Okay. Hello, students. I want to welcome you to college algebra. We're talking about our final exam review session. Now, in this video, we're going to talk about brief content review. So let's get started. All right. Let's see. Let me need to pick a color real quick here. It's my marker. Okay, that's a good color. All right, first thing I want to do is I want to be reminded about working with radicals. So radical 18x cubed, correct? Now remember, I've got a perfect square 9 there, and I have x squared. So that is equivalent to radical 9 times radical x squared times radical 2x, because that's what's left inside the radical, right? Remember, this is 3 and this is x, so it's going to be 3x square root of 2x. Okay, so that would be a way to do that problem. Also remember that whenever I have a radical at the bottom, students, you have to rationalize the denominator. To rationalize the denominator, let me pick a different color, okay? To rationalize the denominator, we're going to have to multiply the top and the bottom by that radical, okay? So when we do that, the top is 1 times radical 2, which is just radical 2, and the bottom is radical 2 times radical 2, which is radical 4. I mean, I could write that, okay? But we all know that radical 4 is just 2. Okay, so this is the answer that I'm looking for that problem. Now, another thing that we need to be familiar with is how to multiply binomials together. All right, so you can do FOIL, you could do box. So I know you know that is 2x squared. That's a 3x minus 4x, which is a minus x minus 6. So we need to go this way, which is multiplying, and this way, which is factoring. Factoring is an essential skill in this class. Let me pick another color real quick. Okay. So, for example, 2x to the fourth minus 8x cubed. Well, let's see. I could pull a 2 and an x to the third power out of each. And of course, remember, you could use your factor training wheels, okay? 2x cubed I'm pulling out of each. So the first one would be x, and then that would be a minus 4. Okay, see how that works? So that is something that you could do to help yourself out. Let me pause this. Okay, another thing that we need to talk about is the idea of a rational expression. Okay? Notice that this is not defined for values that cause the bottom to be 0, so x cannot equal -1. So please keep that in mind. Now remember, on these rational expressions, we could add, if this was x plus 1, then if I was adding those two, that's just the same denominator. But if I was adding these two together, the common denominator would be x squared. Okay, so go back and review that so you know what you're doing there. Now, another thing that's important to keep in mind is if I'm talking about a number line, and let's just say this is -2 and that's 5, and I had a closed circle, an open circle, and this region between, could I write that in interval notation? Well, yeah, you could write this, x is greater than or equal to -2 and less than 5, but that's not interval notation. Remember, this is a bracket, and so you're going to say -2, comma, and then you're going to say 5, and I'm going to use what here? A parenthesis. So please keep that in mind. All right, let's see. Another thing we need to remember is that when we're talking about a polynomial, and I'm talking about the degree of each term, so this term right here, the degree is 3. It's the sum of the powers of the variables of the term. This would be 1, so this would be a degree of 3, this would be a degree of 1, and this would be a degree of 0. So keep that in mind. Now let's talk about numbers for a second. when we're talking about numbers, it's important to know we have a rational number and we have an irrational number. Now, a rational number either has a decimal that stops or a decimal that repeats. Okay, that would be rational. Irrational is the decimal has no pattern and does not repeat. When we say pattern, we mean repeating pattern. Now notice there is a pattern here, but the pattern block, that block is not repeating. Okay, all right. So if it keeps going, okay, and there's no pattern, then it is irrational. Okay, irrational, like pi. Okay, all right. So remember that. Now, when we're talking about quadratics, and we're talking about, for example, let's say I had this statement right here, and I wanted to ask you, can you tell me the critical numbers of f of x? Yes, the critical numbers are 2 and negative 3. They're also the zeros, but they're critical because if I'm trying to find when this function is less than 0 or when it's greater than 0, you remember that procedure. I'm going to use the critical numbers to break my number line into regions. Region 1, regions 2, region 3. Okay, and then I'm going to try to find if it's true or false. If it's greater than 0, it'll be positive. If it's less than 0, it's going to be negative. So just remember that. Another thing we need to talk about is the idea of complex numbers. Complex numbers. Complex numbers are the form of a plus bi. For example, 2 plus 3i. Okay? Now we could take complex numbers and we can add them together. Okay, like for example, I could add these two together. Alright? So we know how to do that. Now we can multiply things together. I would use the box method to do that. But remember, I times I is equal to I squared. And remember, I squared was negative 1. So that, just remember that little review item, and that could help you. The last thing I want to mention over here is the idea of working with rational or inequalities. So here, what I'm going to have to do is I'm going to have to subtract a 1 from both sides. So I'm going to say 2 is less than or equal to 2x, and then I have to divide by 2, and divide by 2. 1. Okay, remember x is greater than or equal to 1. Can you give me the answer in interval notation? Yes, 1 forever, which is infinity. Okay, so keep that in mind. Okay, folks, so remember, when we're working with, and we're talking about working with equations, your job is to get x by itself. And you do that by, getting all your parentheses out of there, then combining your terms, and then moving your x's to one side, and then you end up with something simple. If you have something like 3x plus 1 is equal to 5, then you subtract your constant, okay, and then you divide. X is equal to 4 over 3. That's called a two-step equation. So you're always trying to get these equations into that form so you know what you're doing. All right, now another thing that we need to talk about is solving a quadratic. So a quadratic is of the form ax squared plus bx plus c. Okay, now we're just going to set it equal to 0. My question is, could we solve that? Yes, we can solve that by using the what? By using the quadratic formula. And how did that go? X, that's my values I'm looking for, is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, you do need to know that, folks, so please be aware of that. Now notice I have this, let me move this out of the way. Notice I have this quadratic equation, and I've got different denominators. Remember, what you need to do is multiply both sides by the common denominator. Remember how we did this? This is missing an x, so that's just 2x here. And then this is missing an x plus 1, so you're going to multiply 3 times x plus 1 and put it here. And then this is missing everything, so you're going to take the 4 times both of those, okay? And that's how you're going to set that up to solve that. Okay, now we want to solve this quadratic inequality. We're not necessarily doing the problem. We'll do that on another video, but we're just explaining the concept. You remember how to do this. You can factor this, okay? All right, then we factor this. Remember, the next step is to find the critical values, -2 and -3. We set up our number line with -3, -2, and then we find a critical value here, here, and here. And remember what we're looking for. We are looking for values that are negative, less than 0. And also notice that the endpoints would be considered true. So that helps as well. Go back and review that if you need to, so that you know how to do the problem and know how to write the answer. Okay, folks, remember on the midpoint formula, the x value is just the average of the two x values, and the y value is just the average of the two y values. Okay, we're talking about finding the equation of the line. Now, remember, you're going to have to use the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is x1, y1, x2, y2. And then once you do that, you could plug it in into this equation, the slope-intercept form, or you could plug into point slope form. And some of you guys have your preference, and that's fine, okay? Then you want to work that out. So please keep that in mind. Another question somewhat related to this is, let's just say I have the ordered pair 2, 3. And that's a point, right? It's a point on the corner plane. Can you tell me the equation of the horizontal line? Well, it's going to go through the y value, so that's y is equal to 3. Can you tell me the equation of the vertical line that goes through that point? The vertical line that goes through that point. Yes, the x values are always going to be 2, so it's x equals 2. You notice how the visual kind of helped with that, so do try to keep that in mind. Okay, remember on the systems of equations, you could use substitution or you could use elimination to solve, right? Now, also keep in mind the number of solutions, Most of the time you get an answer like 2, 3, x is 2, y is 3. That will be one solution. But if your numbers drop out like 2 is equal to 2 or 0 is equal to 0, that is all real, okay? Or identity. Now what if I end up with that answer 3 is equal to 2? Well, is that true? Will it be true tomorrow, true yesterday? That is never true. So that's no solution, or that little symbol, which means no answer. Okay? Okay, do remember the distance formula. That's one you need to know. And so here's 2 points, points A and point B. Can you find the distance between those 2 points? Well, it's the square root of the difference in the x's. That's going to be 3 squared, plus the difference in the y's. That's 4. So 4 squared. Okay, and try to, work down neatly here. That's 9 plus 16, which is 25. Of course, the square root of 25 is 5. The distance formula is very, very important, so please remember how to use that. Okay, students, so remember the circle. The circle has a radius, okay, and then it has a center, and then there's a point on the circle. That point goes all the way around points on the circle. Remember, that's just a general point, x, y. So here's the equation of a circle. X minus 8 squared plus y minus k squared is equal to r squared. So remember, h and k are the center. Now, in this particular case, the center is 0, 0. So remember, I'll say this again. Whenever the center is 0, 0, you have an equation that looks like this. Please practice working those problems. Okay, a little bit about slope in the lines. If I had a slope of 2 and have a line that's parallel to it, its slope's going to be 2. And if it was -1/2, it would be -1/2. But if it's perpendicular, it's going to be the opposite reciprocal. So if it's 2, it's going to be -1/2, and it's -1/2, it's going to be 2. So keep that in mind. Okay, those last things I want to remember, of course, a vertical asymptote here is x is equal to 2. Horizontal asymptote, I talked about that on the test 4. Exponential functions have that shape. Equations try to have the same base. Remember, this is a log statement, so 2 cubed is equal to x makes it easy. Okay, that's change of base. Here's an example of change of base. You're going to use this little formula. Rising